Hello and welcome to Algebra 2 Lesson 12. In this video, we're going to learn about compound inequalities. So in our last lesson, we had a review of how to solve a linear inequality in one variable. Now we're going to move on and look at something that's a little bit more challenging and probably new for you in your Algebra 2 course. We're going to talk about compound inequalities. So a compound inequality consists of two inequalities linked by the word and or the word or. Okay, so those are the two different scenarios. Now the first one we're going to deal with is solving a compound inequality with and. Now I suggest you get a flashcard, or if you don't have a flashcard, a piece of loose leaf. Write down the procedure for each one because they're a little bit different. And then as you're working through your problems, you can reference your flashcard or your piece of loose leaf, whatever you wrote it down on. After about 20 or so of these, you're going to have this procedure down packed and you won't get confused. So the first thing you want to do with this scenario of and, you want to solve each inequality separately. Okay, so just treat it as if it's two separate problems. The next thing you want to do is find the solution set for the compound inequality. Now, the solution set contains all numbers that satisfy both inequalities. Both inequalities. So if it's not a solution to both, it's not a solution for the compound inequality. And a good example of this, remember, when we started talking about sets at the very beginning of Algebra 2, we talked about the intersection of two sets. So as an example of that, I have two basic sets here. I have set A, which contains the elements 1, 2, 3, and 4. And I have set B, which contains the elements 3, 5, 7, and 9. So if I'm looking for the elements that are common to both, I'm looking for something known as the intersection of the two sets. So A and B, I want the intersection of the two. This is the symbol for that. And this contains all the elements that are common to both. Well, if you look through here, it's just 3. That's the only element that's common to both. So this set contains one element, and that element is 3. And when we're solving this compound inequality with and, we're doing the same thing. We're looking for the intersection of the two solution sets. All right, so let's get started with the first problem. And we already know how to solve a linear inequality in one variable. That part is simple. It's just putting the two together. All right, so if I have 6 minus 3r is less than 27, I can subtract 6 away from each side of the inequality. So that's going to cancel. I'll have negative 3r is less than 27 minus 6 is 21. Divide both sides of the inequality by negative 3. Remember, if I divide by a negative, I've got to flip the direction of the inequality symbol. So this is a less than, it's going to become a greater than. So this would cancel with this, and I'd have r. And now it's a greater than. 21 divided by negative 3 is negative 7. Now over here, I'm going to solve this one separately. Let me just put a little line here. I'm going to subtract 6 away from each side of the inequality. So I'll have 7r is less than or equal to 48 minus 6 is 42. I'm going to divide each side by 7. And I'll get that r is less than or equal to 6. So I have these two solutions. I'm going to go down to where there's a number line. We're going to do the whole song and dance with the interval notation and graphing. And then we're going to put the two solution sets together. All right, for the first one, and let me just write it out here. We had 6 minus 3r is less than 27. We found that for this one, r was greater than negative 7. So in interval notation, what does that look like? Well, it looks like this. You'd have a parenthesis to say that negative 7 is not included, a comma, and then you'd have an infinity symbol with a parenthesis next to that. So that's interval notation. Graphically on the number line, at negative 7, it's not included. I'd put a parenthesis to show that. And then I would shade everything going to the right, including that arrow. Now, for the next part of the compound inequality, we saw the problem 7 times r plus 6 is less than or equal to 48. And what we found there was that r was less than or equal to 6. So in interval notation, since it's less than or equal to 6, we would have a parenthesis next to negative infinity, comma, and then up to and including 6. So 6 is going to have a bracket next to it. All right. Now graphically, at 6, we put a bracket facing to the left, and we shade everything going in this direction, again, including that arrow. Now, for the compound inequality, let me just write this here. We have 6 minus 3r is less than 27. And then we have 7r plus 6 is less than or equal to 48. So what's the solution here? Well, again, it's the intersection of the two solution sets. And for some people, they like to look at it graphically. For some people, they like to look at it between the two intervals that were created. And some people can just look at it and say, okay, I know it's this. Well, I can tell you that if you just look at the two solutions and you put them together, r is greater than -7 and r is less than or equal to 6. So that's pretty easy to do. You can write that as a 3-part inequality where you say r is greater than -7 and r is also less than or equal to 6. In interval notation, I would write this with a -7 next to a parenthesis to say -7 is not included. And then comma, you have a 6, which is included, so that gets a bracket. Now, graphically, it's easy to tell what it would have been. Here's 6 right here. Kind of think about this as the cutoff for the largest value. 6 is included because this has a bracket here, and in this situation, it's going this way forever and ever and ever. So 6 is included. Now, with -7, it's not included because in this case, it's got a parenthesis there. It's not included there. Okay, so that's your cutoff, anything larger than -7. But kind of anything in between here, anything in between would work as a solution for each of them. So graphically, it's pretty easy to see. Without even referencing this, I know that at -7, I would have a parenthesis because it's not included. I know at 6, I would have a bracket because it is included. And I would shade everything in between. Everything in between. And again, the reason we're doing this is it has to be a solution to each, right? And this is the section of the number line that satisfies both. So again, our solution for the compound inequality is that r is greater than -7, which is displayed here. It's got to be greater than -7. -7 is not included. We put a parenthesis there. And it's also less than or equal to 6. So it could be 6, which is why we have a bracket, and then anything less. So it's this range here. Anything greater than -7 up to and including the number 6. All right, for the next one, we're going to work on one with some fractions involved and nothing we're not used to. So what we have here is 1 plus 8/3 n is greater than -5/3, and we have -n plus 1/2 is greater than -7/6. Again, we want to solve each one separately. So I'm going to start out with 1 plus, we have 8/3 n, and this is greater than -5/3. So I want to clear the denominators. So I'm going to multiply both sides here by 3. And so 3 times 1 is 3, plus 3 times 8/3 is 8, then times n. And this is greater than 3 times -5/3 is -5. Just scroll down a little bit, get a little room going. I would subtract 3 away from each side of the inequality. This will cancel. I will have 8n is greater than -8. Divide each side by 8, and I get n is greater than -1. Okay, so again, n is greater than -1. Now over here, where I have -n, so I have -n plus 1/2 is greater than -7/6. Again, I want to clear the denominators. The LCD here would be 6, right? I've got a 2 and a 6. LCD would be 6. So I multiply both sides of the inequality by 6. 6 times -n is -6n. Plus 6 times 1/2 is 3. 6 cancels with 2 and gives me 3. 3 times 1 is 3. This is greater than -7/6 times 6 is -7. So now let me scroll down a little bit. A little room going. Subtract 3 away from each side. This will cancel. I will have -6n is greater than -10. We will divide each side by -6. Remember, if I divide by a negative, I've got to flip the direction of the inequality symbol. That's a greater than, so now it's going to be a less than. So this cancels with this, and I have n This is less than. Negative 10 over negative 6 is positive. And I know each is divisible by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. So this is positive 5/3. So then again, this was n is less than 5/3. Okay, so we're just going to use one graph this time. And we can put it together and have one solution. So we found that for 1 plus 8/3 n is greater than negative 5/3. The solution was n is greater than negative 1. So in interval notation, that looks like this. You have a parenthesis, a negative 1, comma, infinity, and then a parenthesis. Graphically, we know that at negative 1, we would have a parenthesis, and then we would shade everything to the right. Now I'm going to add something to this. I have and. So we're connecting this. We have negative n plus 1/2 is greater than negative 7/6. We found that the solution for this was n is less than 5/3. So in interval notation, that looks like this. You have negative infinity next to a parenthesis, comma, you'll have 5/3, and that'll be next to a parenthesis as well because it's not included. So graphically, if I look at this, where's 5/3 at? Well, it's basically 1 2/3. So it's something like right here, let's say. There's no notch for it, but let's create one and say this is 5/3. So what I'd be doing is I'd be placing a parenthesis there facing to the left. Okay, and then I would shade everything going this way. Right, going this way. It's easy to see graphically what the intersection would be. It would not include negative 1. It would not include 5/3, but it would include everything in between. So let me erase all of this, and I'll keep those two parentheses there. And I want to shade everything in between. This is my solution for the compound inequality. And I could also write it with n in between. So I could write n in between. And we know that it's greater than negative 1. And it's less than 5/3. All right, let's take a look at another one. So we have 4n plus 7 is less than 9n plus 2. And 13n plus 11 is greater than or equal to 6n plus 11. So let's start out with this one. We have 4n plus 7 is less than 9n plus 2. Let's solve that guy. So I want to subtract 7 from each side. That'll cancel. I also want to subtract 9n from each side. That'll cancel. 4n minus 9n is negative 5n. This is less than 2 minus 7 is negative 5. We divide each side by negative 5. And don't forget to flip this. So right now that's a less than. It's going to become a greater than. And this would cancel with this and give me n. So n is greater than negative 5 over negative 5 is 1. So for this one, we can say that n is greater than 1. For the next one, we have 13n plus 11 is greater than or equal to 6n plus 11. I know if I have the same thing on each side of an inequality or an equation, I could just get rid of it, right? Because I could subtract 11 away from each side, it would cancel. And now I can just subtract 6n away from each side. So I'll have 13n minus 6n, that's 7n, is greater than or equal to, this has all been canceled, so it's 0. Now I divide both sides by 7, and I get n is greater than or equal to 0. So this is n is greater than or equal to 0. So again, we had 4n plus 7 is less than 9n plus 2, and 13n plus 11 is greater than or equal to 6n plus 11. So the solution for this guy was that n is greater than 1. Or we could say in interval notation, you'd have a parenthesis, a 1, an infinity symbol, and a parenthesis. Graphically, I would put a parenthesis at 1, and I'd shade everything to the right. Now for this guy, 13n plus 11 is greater than or equal to 6n plus 11. We found that n was greater than or equal to 0. So in interval notation, you'd have a bracket next to 0 because 0 is included, comma, and then infinity. And you always use a parenthesis there. Now for this one, I'm going to have a bracket that starts at 0, and I'm going to shade everything to the right. So it's pretty easy to see what the solution for the compound inequality is. Anything to the left of 1, and also including 1, doesn't work, because it has to work for both. And it would not be a solution for this original, because here n has to be greater than 1. But anything that's larger than 1 works for both, right? Because both areas are shaded there. And so for the compound inequality, let me just erase this part. It would essentially be the solution for this guy, right? So it would be n is greater than 1. So the solution for the compound inequality is that n is greater than 1, or in interval notation, again, the same thing as this, 1 is not included, but anything larger is. All right, let's take a look at one more with and then we'll start talking about the scenario of or. So we have 19v plus 18 is less than 12v minus 10, and 7v plus 11 is less than 8 plus 10v. So if I start with this first one here, 19v plus 18 is less than 12v minus 10. So I'm going to subtract 12v away from each side. That's going to cancel. I'm going to subtract 18 away from each side. That'll cancel. 19v minus 12v is going to give me 7v. And this is less than. Negative 10 minus 18 is negative 28. Divide each side by 7. And we'll get that v is less than negative 4. So this is v is less than negative 4. All right, for the second part of this, I have that 7v plus 11 is less than 8 plus 10v. Again, what I can do is subtract 10v away from each side. That's going to cancel. 7v minus 10v would give me negative 3v. I would subtract 11 away from each side. That's going to cancel. So negative 3v is less than 8 minus 11 is negative 3. Let me scroll down and get a little room going. I will divide both sides by negative 3. Remember, I'm dividing by a negative, so I've got to flip the direction here. So this becomes a greater than. So this cancels with this. I have v is greater than 1. So this is v is greater than 1. And again, our problem is 19v plus 18 is less than 12v minus 10 and 7v plus 11 is less than 8 plus 10v. Now the solution for this guy right here, we know is v is less than negative 4. So in interval notation, we would say that we have a parenthesis next to negative infinity because it's anything less than negative 4. So up to but not including negative 4. So that's a parenthesis next to that. Graphically at negative 4, I'd put a parenthesis facing to the left, and I would shade everything going this way. And for this guy over here, we found that v was greater than 1. So in interval notation, I put a 1. It's not included, so I have a parenthesis there. Then comma, I have the infinity symbol, parenthesis next to that. Graphically, I'd find 1. I'd put a parenthesis there, and I'd shade everything to the right. Do you see a problem with this scenario? There's a solution for each part of the compound inequality, but the compound inequality itself has no solution. Why is that the case? Because it has to overlap. It has to be a solution for each, and that doesn't exist. There's no solution here. No solution. Because if you look here, for this guy right here, this 7v plus 11 is less than 8 plus 10v, that's satisfied by numbers that are greater than 1. This guy right here, this 19v plus 18 is less than 12v minus 10, that's satisfied by numbers that are less than negative 4. So there is no number that is less than negative 4 and also greater than 1. That doesn't exist, and so there is no solution. Now, one thing that your teacher might want you to do, remember you have a symbol when you have a set that contains no elements. It's the symbol for the null or empty set. You might just want to put no solution and then put this symbol if you get this scenario. All right, now let's talk about solving a compound inequality with the word or. So again, you want to solve each inequality separately. So you always do that part. The next part is a little bit easier, actually. You just say the solution set contains all numbers that satisfy either inequality. So it doesn't matter if it's a solution to only one of them, or it could be a solution to both. Either way, it's going to be a solution for the compound inequality. So as an example with sets, I go back to my set A and set B. If I want the union of these two sets, so the union of A and B is equal to what? Well, everything goes in. The only thing you got to make sure of is if you have an element that's common to both, you list it only once, okay? Only once. So you have 1, 2, 3 only gets listed once, then 4, then 5, then 7, then 9. So the union of these two sets is all the elements combined. Again, nothing gets double listed. So each and every element from A, along with every element from B, is an element of this set. All right, so let's look at the first problem. We have 5k plus 2 is greater than 32, or k plus 5 is less than or equal to 9. So I want to subtract 2 away from each side over here. I'll have 5k is greater than 30. I'll divide each side by 5, and I'll get k is greater than 6. So then we have OR. So we have this one over here. Subtract 5 away from each side. I'll have k is less than or equal to 4. So again, we have 5k plus 2 is greater than 32. Or we have k plus 5 is less than or equal to 9. So for this guy, we found that k was greater than 6. In an interval notation that looks like this, you have 6 comma infinity with a parenthesis at each end. Graphically, I'd put a parenthesis at 6 that faces to the right, and I'd shade everything to the right. Then for k plus 5 is less than or equal to 9, we found that k was less than or equal to 4. So in interval notation, I'd have a negative infinity, comma, a 4, with a bracket next to 4 and a parenthesis next to negative infinity. So I'd find 4, I'd put a bracket facing to the left, because anything less than, and I'd shade all of this to the left. Now, we just saw that if we had the connective word and, we don't have a solution, right? Because nothing is going to overlap. There's no intersection between the two solution sets. But with OR, it's different. It can be a solution to this guy or this guy. It's a solution for the compound inequality. So our solution set is written like this. We would say that we have this set, so negative infinity up to and including 4. It's the union of this, I'm going to put the union symbol, with this guy. So anything greater than 6 out to infinity. So it's the union of the two sets. And graphically, I don't need to do anything else. It's 4 or anything less, so that's all part of the solution. And then anything greater than 6. So here's your solution using interval notation, and here it is graphically. And then additionally, you could write it just saying that k is less than or equal to 4, or, just put the word or, k is greater than 6. All right, for the next one, we're looking at 2/5 p minus 4/3 is less than 2p plus 1/4, or 3/4 p plus 12/5 is less than or equal to 6/5 p plus 3/2. All right, so let's start out with this guy right here. So I have 2/5 p minus 4/3 is less than 2p plus 1/4. So I want to clear my denominators. And the LCD here would be 4 times 3 times 5, or 60. So let me multiply both sides by 60. 60 times 2/5. 60 would cancel with 5 and give me 12. 12 times 2 is 24. So this would be 24p. Then minus 60 times 4/3. 60 divided by 3 is 20. 20 times 4 is 80. This is less than 60 times 2p is 120p. Then plus 60 times 1/4. 60 divided by 4 is 15. 15 times 1 is 15. So then what I can do is add 80 to each side. And I can subtract 120p from each side. So this is going to cancel, and this is going to cancel. 24 minus 120 is negative 96. So this would be negative 96p. And then it's less than 15 plus 80 is 95. So if I divide both sides by negative 96, remember I've got to flip the direction of this guy. This becomes a greater than now. I'll have p is greater than 95 over 96. And because this is negative here, I'll put a negative out in front. So p is greater than negative 95 over 96. So p is greater than negative 95 over 96. Now we'll deal with this one. So let's scroll down a little bit. So I have 3/4 p plus 12/5 is less than or equal to 6/5 p plus 3/2. So the LCD here would be what? We have 2, 4, 5. So basically it'd be 4 times 5 or 20. So we'll multiply both sides by 20. And so 20 times 3/4, 20 would cancel with 4 and give me 5. 5 times 3 is 15. So this is 15p. Plus 20 times 12/5. 20 would cancel with 5 and give me 4. 4 times 12 is 48. This is less than or equal to 20 times 6/5 p. 20 would cancel with 5 and give me 4. 4 times 6 is 24. Then times p. Then plus 20 times 3/2. 20 would cancel with 2 and give me 10. 10 times 3 is 30. All right. So we can now subtract 24p away from each side. Cancel this. You can subtract 48 away from each side. Cancel this. 15p minus 24p is negative 9p. And this is less than or equal to 30 minus 48 is negative 18. We divide each side by negative 9. And again, we've got to flip the direction of the inequality symbol. So this becomes a greater than or equal to. So this cancels. We have p is greater than or equal to. Negative 18 over negative 9 is 2. So p is greater than or equal to 2. So again, I had 2/5 p minus 4/3 is less than 2p plus 1/4. Or the other one was 3/4 times p plus 12/5 is less than or equal to 6/5 p plus 3/2. Now for this guy right here, we found that p was greater than negative 95 over 96. So in interval notation, that looks like this. We would have a parenthesis, then negative 95 over 96, and then out to infinity. Of course, you use a parenthesis with that as well. For this guy, we found that the solution was p is greater than or equal to 2. So in interval notation, you have a bracket, and then you have 2, and then out to infinity. So you put a parenthesis there. Graphically, you can think about this one right here, negative 95 over 96. That's going to be a little bit to the right of negative 1, because it's not quite negative 1. It's a little bit larger. It's a little bit to the right of it, okay? If I had negative 96 over 96, that equals negative 1. This is a little bit shy of that. So let's just put that right here, let's say. Let's say this is negative 95 over 96. And it's anything larger than that, but not including that. So I'd put a parenthesis facing to the right, and I'd shade all of this. Now, the other guy was anything greater than or equal to 2. So that would be right here, and I would shade everything to the right. Now, for the compound inequality, it could be a solution to either. So we would go with this solution right here because it encompasses both. It encompasses this one and this one. So I can erase this part right here and just say that, and I can shade this in any color I want. Let's just do red. This is the solution for the compound inequality and for this inequality. So the solution for the compound inequality is just this guy right here. We'll put a parenthesis, negative 95 over 96, comma, infinity. Another parenthesis. This is graphically. And then we could also just say it's p is greater than negative 95 over 96, because this solution contains completely this solution. And again, if it's a solution to either, it's a solution for the compound inequality with OR. All right, let's take a look at one final problem. So we have 2x plus 1 is less than negative 19 plus 7x, or 3 plus 15x is less than or equal to 10x plus 18. So let me solve this first guy up here. So we have 2x plus 1 is less than negative 19 plus 7x. What I want to do is I want to subtract 1 away from each side, and I want to subtract 7x away from each side. So that's going to cancel. Let me scroll down and get a little room going. So 2x minus 7x is negative 5x. This is less than negative 19 minus 1 is negative 20. Divide each side by negative 5. Again, flip the direction of this guy. So that's now a greater than. This cancels with this, and I'll have x is greater than. Negative 20 over negative 5 is 4. So here, x is greater than 4. All right, for this guy right here, I could subtract 3 away from each side. So that would cancel. And I could subtract 10x away from each side. So that would cancel. 15x minus 10x is 5x. And this is less than or equal to 18 minus 3 is 15. We divide each side by 5. And we get that x is less than or equal to 3. So this is x is less than or equal to 3. All right, so we have that 2x plus 1 is less than negative 19 plus 7x, then or we have the other scenario, 3 plus 15x is less than or equal to 10x plus 18. So for this guy, we found that the solution was x is greater than 4. So in interval notation, we would say that we would put a parenthesis at 4, and then anything out forever and ever and ever, so we put infinity here. And then graphically, at 4, I'd put a parenthesis facing to the right, and I'd shade all of this. Now for this guy right here, we found that x was less than or equal to 3. So in interval notation, there's no smallest value, so we put negative infinity, put a parenthesis next to that. And it's going up to and including 3, so we put a bracket next to 3. Graphically, I put a bracket at 3, facing to the left, and then I shade everything to the left, and I'm going to shade this arrow. Now, you can see that there's no overlap between the two solutions. So if this wasn't an or, if this was an and, you would have no solution for the compound inequality. But because this is or, and it can be a solution to either, to be a solution for the compound inequality, it's the union of the two solution sets. So in other words, it is this guy right here. So it's negative infinity up to and including 3. It's the union with this guy. We have 4, that's not included. We have the parenthesis there, out to infinity. Graphically, it's just this. I don't need to change anything. I've graphed each one, so I don't need to do anything else. And then you could also write it as saying x is less than or equal to 3, or x is greater than 4. Each of these would show you the solution for that compound inequality.